Hey guys, hopefully this is the last video for this chapter. Unless you guys need an overview or a review or something like that, just please reach out to me and let me know. So I can get back to you like Monday through Friday and have it done for you. All right, so again, learning outcomes for you guys. Make sure that you are comfortable with these and you're asking questions if you're not. And you don't have to ask each other, you can ask me. And I don't judge. You guys are in college to learn. So all right, antagonistic one. This is kind of if you think of or antagonistic effect. If you think of like a villain and a hero or a heroine, um, the results. Oh no, my pen is not on. Stupid pen. We'll do dead time. Okay. If you have a hero and a villain, I don't know if you guys will be able to see this, but it's a balance between. So I don't know if you guys watch Star Wars, but like the dark side and the light side or whatever. Synergistic is an additive effect, so you have one helping another, because this is two or more hormones, or two hormones at a time. Okay, so then one's helping the other. So in microbiology, the synergistic effect would be if you prescribe to your patient 2 antibiotics, and when they're combined, they're stronger. So they have an additive effect. Or where's the little guy? There he is. They have an additive effect. The permissive effect is you need one hormone for another to get the effect produced. So you basically one hormone is needed for another effect to be felt. You need permission from one hormone to get the other one to have its impact working. That's another way to say that. And then integrative hormones, they're very similar to synergistic, but they have different results, even though these results complement each other. If that makes sense, I hope it does. These ones you guys want to pay attention to for growth, and make sure you guys know which ones are important for growth. And we're going to do an entire chapter on reproductive, not just hormones, but reproduction and development. There's another chapter for that. But these will be important. If you don't get certain hormones, you won't, whether it's while you're in utero as a not an unborn child, up to 40 weeks, or it's adolescent prior to puberty. You're not going to develop the correct, or not. You're not going to develop. You're going to be underdeveloped, or you're going to have incomplete secondary sex characteristics that can lead to sterility. So, in children, both children, regardless of sex, need growth hormone, human growth hormone, to build up muscle and skeletal development. You also need anybody, Bueller, testosterone and androgens. Okay. In adults, you have to maintain normal blood glucose, which is 70 to 110 milligrams per deciliter. And then you have to have the ability to mobilize lipids, and specifically the reserved lipids we save as adults. And women are typically, women are typically healthy. Why is my thing not showing up? I'm changing the color because I can't see it. See that one better, maybe. Women are typically considered healthy, as far as body fat, when they're between, I think it's 16 and 22% body fat. And this is athlete or not athlete, though it can be much lower in female athletes. And then males, it's usually like, it's a fair bit lower. It's like 14 to 19% body fat in males to be fertile and function appropriately. Okay, so thyroid hormones, if they're not present during fetal development, That's an ugly line. Uh, or if they're not present after the first year of birth, the nervous system will not develop correctly, or I should say normally. And then you have developmental delays. So this is why in the majority of states in the United States, we have a food program called WIC. And some people call it food stamps, but that's not really correct. Um, and it makes sure that, well, I mean, it gives the parent, whoever is taking care of the child, the ability to purchase food to make sure that the mom is on prenatals, and that when the baby is here, the baby is getting enough um, of the correct nutrients to make the thyroid hormones needed to develop correctly. So if you have T4 shortages prior to hitting puberty, the skeleton, regardless of sex, won't develop, will not even continue to develop. And I haven't really heard very much luck about getting that kick-started. But all right, insulin, again, gets the passage of glucose and amino acids through the plasma membranes. Hold on a second. I love you, Flerkin. Leave me alone. I'm working. Kind of rhymed. Sorry. All right. So he's very upset. He wants in. Okay. Insulin gets the glucose that we consume from our diet and amino acids we took in across plasma membranes and allows for cells to grow. There's another hormone that I mentioned with cell growth. Anybody? Anybody? Oh, it got all ugly. Estrogen is what that's supposed to say. All right, parathyroid hormone and calcitriol promote the absorption of calcium salts from your bloodstream to be deposited into your blood. Into your blood. You just pull them from your blood. You pull them from your blood and deposit them into your bone. And the word is deposition, but I don't like that because I feel like it has a legal connotation. Blah. All right. Inadequate levels of parathyroid hormone will result in weak and flexible bones that cannot bear weight, and it's actually kind of sad. And this is one of the genetic factors that is linked on to some of the people who are genetically predisposed to brittle bone syndrome. I'm not sure I'm getting that right. Don't worry, it's just an idea, or it was just a factoid I was trying to share with you guys. All right, reproductive hormones. This is so sexist. Both sexes. So you can guarantee there's going to be a question on the test. Like, if not one, there's going to be 3 versions of it. And you guys will see one of the 3 versions. Both males and females need estrogen and testosterone to grow and reproduce. I don't know who wrote this, but I do know who wrote it. I'm sending them an email. Fix this. Actually, I fixed the PowerPoint and I thought I caught them all. Anyways, okay. But they will stimulate the growth and differentiation in target tissues, whether that's uterine lining, and oocysts and sites and ovaries, or it's epithelial and nerve cells and testes. All right, so we do see gender-related differences in skeletal proportions. So males tend to end up being taller and broader, and like if you think of shoulders, the width of shoulders, where women end up being generally of shorter stature, but there are hips and legs end up being broader, and our femurs end up being a little bit thicker by proportion. And the secondary sex characteristics, speaking of, which we'll go into more detail later, would be like pubic hair, facial hair for men, armpit hair for both sexes, menstruation for women, and sperm production for males. All right, so stress. Let's get this bad boy done with. I don't like this abbreviation or acronym because it spells gas, and nobody likes gas unless it's in your gas tank. Okay. But any situation that threatens homeostasis, whether it's change in calcium or sugar or temperature, whatever. It used to be called the distress response, but now everybody commonly calls it the stress response. So, how do we react to stress causing factors? We divide it into 3 phases: alarm, resistance, and enthusiasm. Not enthusiasm. So tired. Exhaustion. All right. So alarm phase is the first one. It's an immediate response. It is directed by the autonomic nervous system. But for that part, your body is mainly going to um, start to use energy reserves like glycogen into glucose. And your body will immediately start to go into a fight or flight response. And the dominant hormone here is epinephrine. Correct. So resistance. So this is occurring as stress lasts longer than a few hours. It can be weeks or months. And all that time, the steroids, glucocorticosteroids are beating up your brain, and they are the dominant hormones. And these are the stress hormones or distress hormones that can cause short-term memory loss. They can cause fatigue. They can cause all kinds of issues. And here is, instead of using glucose and glycogen, we're actually going to start to burn into our lipid and amino acid reserves. And then the glucose is literally conserved for your brain because, like I mentioned earlier, that's the only sugar your brain can use. It cannot use glycogen. All right, general adaptation syndrome. This is over years. Basically, the homeostatic regulation is broken down. Your body can no longer deal with it. The first thing we'll see is, actually, the first thing we'll see is one of the first things we'll see is aldosterone production stays while we lose potassium. And then eventually one of the organ systems is going to fail and it ends up being fatal. And sometimes it's the cardiac system, sometimes it's the nervous system, whether it's autonomic or um, non. But it can lead to cardiac issues, nervous conditions, all kinds of different things. If you have a massive myocardial infarction, basically a heart attack, from prolonged stress, there's no coming back from that. Other people present differently, and sometimes their kidneys and liver will shut down. So it just depends on the individual. Hormone changes definitely affect behavior. That's why I was bringing up the don't abuse steroids talk. It affects your intellectual capabilities, which is why I called them roid ragers. If you're not eating correctly, it's going to impact memory as well as learning. You are what you eat. And I get that students are hungry. I was once a hungry student too. But you still have to eat and take care of yourself to properly learn. And learning is an action word. So it can also impact your emotional states. So as we age, some things do change. Our reproductive hormones decline, especially in women. They will decline in men, but men are actually, we have a lot of evidence that human males remain fertile into their 90s, where women do not. And it varies based on genetics, but anywhere from 30s to the 60s, women become no longer, they're no longer fertile. Okay. And then based on stimulation, endocrine tissues become less responsive to the stimulation I'm sorry, I should have said based on age. So you can stimulate them, but if you're really old, I say really old, you guys are like, she's really old. Um, uh, After 24 to 28 years old, it doesn't matter how much you stimulate certain endocrine tissues like your thyroid, it's not going to get any bigger or better or badder. And this is the overview of the system, which, there you can see right there. It's a little tiny bit of the pancreas. That's what I was trying to show you guys earlier. Okay, So I'm going to stop and I'm going to post these links up for you guys as soon as possible. And hopefully I'll get to see you guys in a Zoom this week. All right. Take care. See you guys soon.